think that would be worth doing. I think Kurt was on to a very good idea there, and I'd like to take this model that we've built and to really try to convey the essence of how it works. I just want to run through to give you some concrete sense as to really what's going on. So we built it up in a certain way with certain goals in mind in terms of flexibility. Those are going to be underlying my comments, but I just want to give a sense as to the overall flow of what's happening. So we start here, to run this model, we start by requesting that an experiment run, right? We right-click on one of these experiments and we select run. So we run an experiment, right? And a given experiment, when we run it, there's some details, but basically it is going to provide some information to main to tell it how to run. And the type of information that it gives is going to be provided through parameters. Parameters are going to tell main what assumptions main should make and communicate those assumptions to it, right? So we're going to tell it, because we have 3 parameters in main here, a population size, a connection distance threshold, how far people have to be apart to be connected, and a fraction initially infected. We're going to be telling main the values of those to use. So main knows, what should I assume about these things? Main has these parameters, and it needs to know what value should I assign to these parameters to do my job. And that's what experiment's going to tell. It's going to say, so this given experiment that's selected now, population size 250, it says to main, essentially, you're going to use 250 people for your population size, 75 for your connection distance threshold, and 0.05 for your fraction initially infected. Now, some of those happen to differ from the baseline values, as highlighted, and others not. But fundamentally, it's telling it to run it with these parameters. The indication of which differ from the baseline is just for our thinking through what does this given experiment mean? What's that scenario designed to what's the intention of that scenario? What's the motivation behind it? So when we run this experiment, it's going to tell main to use each value for the parameters. And then main goes off. And it's going to do its job. So here we have main. And main is told by experiment what values to use for each of these parameters, right? Population size, connection distance threshold, and fraction infected. And some of those it can act on absolutely immediately. For example, this guy, population size, is used from the get-go to set the initial number of agents in that population, right? It sets the number of agents based on that parameter. So it's told by the experiment, use 250, so it creates a population of size 250. That's great. And in creating them, more than that, it actually, in creating them, it actually wires them up to who they're connected with. And if we used a distance-based network, it would use this connection distance threshold parameter to determine who's connected to whom. 2 people, a given pair of people, A and B, are connected if and only if they lie within this distance. So when main creates its population and lays them out, it's going to use some of these parameters to figure out who's connected with who, or where they live, or what have you, where they're located. Okay, ladies and gentlemen. And then it's got to go through and create each for those people in the population in turn. So it says, okay, I've got 250 people in this particular case to create. My population size is 250. For each of those people in that population size, I've got to create a person. Where are they going to live? Well, that's based on the layout within main. This layout we just saw here, it's going to be a ring layout. Okay, I've got to lay them out along this ring. Who are they connected to? Well, that will be based on this and this threshold. But in terms of the other attributes of that person, those are set by this population here. And really, there's only one attribute right now, which is determined for each person in turn. For each of those 250 people, it's going to be saying in turn, Okay, first person. It's going to say, okay, I've got to figure out whether it's initially infected or not. I've got to tell this new person as they come into being whether or not they're initially infected. How am I going to do that? I am going to run this little formula. And this formula basically is like a flip of a coin, of a biased coin, a coin that could be weighted, so it's more likely to be true or false. Here, the value it happens to hold from this experiment is 0.05. So this value of fraction initially infected is 0.05. So that means only 1 out of 20 times will that coin come heads up. So it's a really unfair coin. The tail of it is very, very light. And so most of the time it turns out false. It turns out tails up, other than heads up. But about 1 out of 20 times it turns up should be true. So about 1 out of 20 times random true would be true, otherwise it would be false, because fraction initially infected is 0.05 for 1 over 20. Okay, so for each person to be created, it flips this coin. It calls random true with 0.05 and it gets back a true or false. And for that person, it uses that for the is initially infected parameter. Next, it creates the next person. It's got to determine the parameters for that person. There's only one parameter, is initially infected. It flips the coin, it gets true or false, and it says, is initially infected is this, or true, or is initially infected is false, depending on what random true returns. For the next person, it flips it again and tells them, your is initially infected is such and such, true or false. Next one, flips the coin again, tells it whether it is initially infected, true or false. It does that for all 250 of the people. And each of those people, having been created, now they know what their initially infected is. Who told them? The population told them when it was doing it one by one by one, just as I told you. So they get created by the population with these characteristics, and this person therefore knows when they're created, my is initially infected is true, or mine is false. So for that particular person, it's either true or false. And based on that, they will enter their state chart, and they will either go this way if it is true. If they've been told is initially infected is true, coming into being, if that's their birthmark, then they're going to go this way. Otherwise, they're going to go this way. That's what this says. So if this condition here is true, they're going to go down and start in the infective state. Otherwise, by default, they're going to start here. And so that person is going to come into being starting either in susceptible or in infective according to the value of their is initially infected. After that, their life takes place according to the rules specified by the state chart. So once they enter here, for example, their color is set to green, or enter here, their color is set to red. If they are entering this state here with a certain rate, they'll have contact with others, and then they will go on eventually after exactly 3 days to recovered. And they go on and start to proceed in their life. Does that make sense in terms of the overall flow here? So the experiment creates main, tells it what to assume in terms of its 3 parameters. Population size, the fraction that is initially infected, and then the connection distance range. And then main creates this population, and one by one tells each person in the population what to assume for its initially infected. In other words, what to assume for its parameters, which is only 1 here by chance. And having been told that, the person comes into being, knows the full value of its parameters, and does the appropriate things. Okay? So that's how this works. Make sense? Okay. Great. So I'm going to stop.